Hello students, welcome back again to study physics lesson. Guys, chapter 2 already finished all chapter 2. Now we are at the end of each chapter. As you know, we have some questions review. So we are in this page to solve the important question. Actually, because there is so many questions, I'm gonna solve the important one that is so important for you. Okay, guys. Chapter 2 review page. It's page 45. Question 1. Look back. Classify the three phases of matter according to their density and interrupt density difference. Guys, as you know, we have three phases of matter. We studied all the three phases of matter. First phase, it was solid. Second phase of matter, liquid. And the third phase of matter is gas. So three phases of matter we studied. So the question said classify according to their density. So it means that which one of them has lowest density and like order from the lowest density to the greatest density. So guys, this is the three state of matter. Which one of them among these three of state of matter, which one of them has a lowest density? Guys, the lowest density actually gas has a lowest density. So first, gas has a lowest density. Why? Because we know the difference, the distance between the atoms is so large, there is a weak force between them. That's why their density is small. So it's dependent distance. So gas has lowest density. Second, liquid. So first gas, lowest density, then liquid, the last one solid. So solid has a greatest density because the distance between the atoms is so close, so close. So we have a large force, and since that's why we have a large density. So from the lowest density phase, gas, then liquid, then solid. Okay. Question 2. In which phase of matter do molecules have more organized location? Guys, among the three phases of matter, solid and liquid and gas, and even we studied which one of them has like their structure is organized, it's regular. Of course solid, because if you know that we studied the structure of solid, all of the molecules, they are next to each other. They are regular. Now look, the structure of the molecule, the particle, the atom, the molecule, they are combined. They are so regular. Look, atoms and atom, molecule and molecule, and they are next to each other. They are arranged. So that's why the structure of solids is regular. It's organized. So the answer is solid. Okay. Question 3 is not that much important. Question 4. It's a good question. Why is the largest part of space in a plasma phase? Why most of the part of the space plasma phase? Guys, because as we know, we said the structure, the composition of plasma is consists to what? Is atom and nuclear and electron, they are moving very high speed. And we know that 90% all matter is consists universe plasma. It means that 90% all of the matter, all of 90% all of the matter in the universe is plasma. In the universe, is plasma. That's right. This is the reason why largest part of the space is plasma, because 90% of the matter in universe is plasma. And even we say the structure of the plasma is electron nuclear, and they are moving very high speeds, and their plasma is occurred at very high temperature. Okay. Question 7 is a good question. Why it's easier to compress gas than liquid and solid? Guys, if you remember, before to study the chapter 2, I showed you the table different between the property of the gas and liquid and solid. So we studied even solid is incompressible. We cannot even apply any pressure on the solid. Liquid, it's compressible in a small extent, but gas, it's compressible. We can make a lot of pressure on gas. What was the reason? Because the distance between the atoms are so far. Look the distance. So that's why we can easiest apply pressure on the gas, because the distance between the molecule of the gas are so far, and they have a lot of distance between the molecule. That's why we can apply the pressure easiest. So the answer, because atom in gas, because atom in gas, they are too far with each other. They are too far with each other. Atom in gas, they are too far with each other because of the distance. Question 9. Define ionic bonding and give an example. Guys, we studied 3 types of the bonds: ionic bonds, covalent bond, and even metallic bond. What was ionic bond, guys? If you remember, ionic bond is by losing electron and gaining electron. How we studied that, for example, NaCl. The Na atoms around the atoms. Look, I'm going to write in here. Look, for example, we have an atom. Around the atom we have this atom. Around the atom we have electrons, and then this sodium is, they would like to kick the electron out, and directly Cl's atom immediately they will receive this electron. So look, by gaining and losing electrons. So in general, ionic bond is a chemical form is between two ions with opposite charge. Of course, between a negative and positive charge. It's by giving up one electrons or more to another electrons. So the answer, we can write the answer of this question. Question 9. We can answer shortly, not too long. The bond between two opposite charge. Opposite charge. When atom gives electron or more to another, for example NaCl. So this is the answer of question 9. Ionic bonding is a bond between two opposite charge when the atoms gives one electron or more to another. So this is the answer of question 9. Okay. Question 10. Now defined define now covalent bond. Guys, now we solved question 9. Ionic bond by gaining or give electron, but covalent bond, as we studied, they don't have ability to lose or gain electron. But covalent bond, for example, if you have two atoms, for example, O2, O2. These two atoms, they are sharing electron. Look, they are sharing electron. These two atoms, they are sharing electron. They are sharing electron, these two atoms, except to lose or gaining electron. So a covalent bond, they don't have ability to lose or gain electrons, just they have to share electrons. Just you can write sharing electron. Sharing electron between two atoms. They are share electrons. For example, now I wrote the example. For example, O2, oxygen. Okay. Let me check. Okay, question 11 done. Question 13 is good. Question 13. Look. Why is ionic bonding stronger than covalent bond? Why the bond? Why the bonds of ionic bond is stronger than the covalent bond? Guys, because the energy of the bonding ion is stronger than the energy of the covalent bond. This is the reason. Just because of the energy. Because energy of ionic bond, because the energy of the ionic bond is much more than the energy of covalent bond. Covalent bond. Okay. The answer of question 13. Question 14. The molar mass. This calculation. The molar mass of sodium is 23 gram. Good. The molar mass of sodium, 23 gram. Molar mass, you know, it means M capital, M small. And its molar volume, it's written even Vm, molar volume. Estimate the density of the sodium atom. So find the density. Yani find what? Rho. Density. Easy. We studied the rule. The rule of density equal to molar mass over molar volume. The rule. So we know the molar mass is 23. Guys, because the unit of density in SI is by kilogram per meter cube, so we have to convert the gram 23 to kilogram by times 10 power negative 3, and the Vm volume is written 23.78 times 10 power negative 6. You can use calculator. So the answer of the density, part A, 9.7 times 10 power 2 kilogram per meter cube. So just find the density and you have the rules, and that's all easy. Part B, calculate approximate mass of 1 mole of 1 molecules of sodium. Of 1 molecules, guys. We have this rule too. The mass for one atom or the mass for one molecule. look. Sorry, look, Baba, huh? Wait a minute, so it's like that. Let me fix it. Let me erase this question. Okay. Part B, calculate for one molecule. So what was the rule to find the mass for one molecules? Mass equal molar mass over Avogadro number. Molar mass over Avogadro number. Good. Equal. We have molar mass. It's 23. Again, make it kilograms better. Times 10 power negative 3 over Avogadro number, guys. You should memorize it. It's 6.02 times 10 power 23. So divide both. The mass for one atom is equal to 3.8 times 10 power negative 26 kilogram. So this is the mass for one atom. This is the rule, molar mass of Avogadro number. We solved part B2. Question 14 is good, important. Question 15. Question 15. Guys, look. Question 15. Estimate the density of the silicon, even its molar mass, written again, molar mass. It means M capital, M small. And its molar volume, it's written true. So find the density. Again, the rule of density easy, equal to molar mass over molar volume. Okay. The molar mass we have, it's 28.0855. Guys, again, it's gram. Make it kilogram because the density is unit by kilogram. That's why in SI. So 28.0855 times 10 power negative 3 because we have to make it. Wait a minute. There is no space. Let me fix it. Okay. So the rule density equal to molar mass over molar volume. 28.0855 times 10 power and negative 3 because you have to make it kilogram over molar volume 1.206 times 10 power negative 5 meter cube. Done. Just divide it. So the density equal to 2.33 times 10 power 3 kilogram per meter cube. So the answer of question 15. Just rule. You can just apply rule. There's not even new idea. Okay. Question. So already finished question 15. Question 17. Distinguish or what is the difference or separate between a rigid and non-rigid solid? Guys, the difference between them and even we studied a rigid body. A rigid body a body that can preserve their shape a body that can preserve their shape Guys, for example, you have any structure, any shape can preserve the shape when you apply force on it. When apply force on it. Apply force on it. So a body can preserve their shape when apply force on it without breaking this, but non-rigid. Same but opposite. Same thing but opposite. A body non-rigid, non-rigid body cannot preserve their they cannot preserve their shape. They cannot preserve their shape after applying force. So a body cannot preserve their shape after applying force. Question 18. Difference between elastic and non-elastic. Elastic is the ability of any object after when you apply a force, anything, they have ability to restore back to the original shape. For example, how we studied sponge or spring, sleeping mattress, all we studied. So elastic the ability of body to restore its original shape. To restore original shape. After applying force. After apply force. After applying force. So look, elastic, the ability of body to restore original shape after applying force. But what if I make it so it's elastic? What about non-elastic? Non-elastic, same thing, the ability of body, same thing, but the body cannot the body cannot restore to original shape after applying force. This is the difference between elastic and non-elastic. Okay, guys. Question 20, important difference between stress applied on a given material and resulting of strain. Guys, as you know, stress, this is the symbol of stress, and strain, this is the symbol of strain. We know strain is equal to what? L minus L naught over L naught, but stress is equal to T over area. So the difference between them, first, the unit, stress is unitless. stress. Sorry. Strain is unitless, and we studied why it's unitless. Unitless because this is meter and that one is meter 2. It's gonna be cancelled, so no unit is left. So strain is unitless, but the unit of stress, it's Newton over meter square. So the first difference, strain is unitless, but stress you have a unit. The second difference, stress is the relation between tension over area, but strain is the relation between elongation to initial length. So by the rule, we can get a difference. This is the rule of each one of them, and the strain is unitless, but stress you have unit. Strain is elongation to L naught, but stress is force tension over area. Okay. What about question 22? Difference between tension strain and the shear strain in given graphical interpretation. Guys, question 22. Look, the difference between tension strain. In general, there was the difference between tension stress and shear stress. This is wrong, guys. Tension should be tension stress. Tension stress, not tension stress. But anyway, in general, the difference between tension stress and shear stress. Difference between tension stress and shear stress. Guys, in shear stress, if you remember, we said the applying force, for example, we have the wire, we have this wire. The applying force is perpendicular, so you have a 90-degree shear stress. Sorry, tension stress. I mean, the angle is 90 degrees perpendicular tension stress. But shear stress, we have, for example, you remember we studied, you have this object. The tension is coming to intersect the surface of the object. The surface, this intersect this point. So this is called shear stress. And in general, just this is the rule. This is the difference between them. Shear stress 90-degree. Tension stress, tension stress 90-degree, but shear stress it intersects the surface of the object, and it's called tangent. If you remember, tangent shear stress, but tension is perpendicular. Okay. Question 23. Define Young modulus for the given matter and specify its unit. Guys, the unit of Young modulus is measured by E. Young modulus rules, even we proved it was stress over strain. And we said the rule it was T L naught over area L minus L naught. The rule of Young modulus, and the unit, it's specify the unit. The unit, the tension, it's measured by Newton, and L naught meter, area meter square, and L minus L naught all meter. So we studied the meter cancel. So even when we studied the unit of Young modulus, it was Newton over meter square. So what define Young modulus? What's Young modulus? Is the relation or between stress to strain. Stress to strain. Good. Guys, most of the question we studied all actually. So just I would like to solve one question. Is important. You have guys, those questions really, some of them is not important. The thing that we study is important in that page. The others you can study by yourself. If there is any question, you can inform me, and this is enough actually. Because most of the questions the same. Again, we studied all. Just question 36, it's new, and I love this question part. It's important, guys. Look, consider two identical springs. Consider we have two identical springs, each of initial length 300 millimeter. 300 millimeter. Look, guys, we have two identical springs, 1, 2, and each of initial length, يعني for both of them, L naught equal to 300 meter. This one too, L naught equal to 300 meter. And even this K for both, again, 400, need the K constant. Calculate the elongation of each spring. For both, find the springs. It means L minus L naught. Find L minus L naught for both spring. Okay, guys, let me solve the first picture. Find L minus L naught for this picture first. Okay, guys, we have to apply the Hooke's law question. T equal to K bracket L minus L naught. Find L minus L naught, divide both sides by L minus L naught, so L minus L naught equal to K and T up. Okay, guys, for the picture it's written the tension or the weight of this is 10 Newton, and this is the force or the weight of the two spring, this two spring is suspended. This is the weight for both, and this 10 unit is the weight for both of the spring, so 10 unit, and the K constant is 4. The K constant is 400. You can divide it easy, so L minus L naught equal to 2.5 times 10 power negative 2 meter. So this is the elongation of the first spring. Spring. Guys, the new thing is again here. You should understand. This 10 unit, this object, this two spring is suspended by this object. This 10 unit is the weight for both of the spring. This 10 is weight for the both springs. So for both of them it's 10. That's why I immediately wrote 10. But part B, look, part B, I have to apply same rule. Again, find elongation. Find elongation for this picture. Again, T equal to K L minus L naught. L minus L naught equal to K down and T up. Okay, same, K is 400. But be careful. In that case, it's written the rod of weight is 10 Newton. What that mean, guys? This question is different, not like the previous one, because the previous one, this 10 unit is the weight for both of the spring. But no, in this case, this rod, the weight of this rod is 10. What that mean? It means the 5 weight for the first spring, the other 5 for the second spring. So because 5 with 5 is gonna be 10. That's why this 10, this T tension, this weight, you have divide for both. Each of the springs is took 5 Newton, 5 Newton. That's why the weight of the rod is 10 Newton. Because look, At this side, the spring is suspended by this side. The spring is suspended with this side. The other side, the spring is suspended by the right side. So that means each side it's took 5 into 5 Newton. That's why it's become 10. Look, this metal, this wire, we know has two sides. The right side is suspended by this spring. The left side is suspended by this spring. So each of the sides is took 5 into 5 Newton. So that's why, because you have to find the elongation of each spring, so you should divide the tension. It's 10 actually. 10 divided by 2 is gonna be 5. So elongation of each spring, look, it's 5. Look, so that's why instead of the t, we have to write 5. So 5 divided by 400, it's 1.25 times 10 power negative 2 meter. Why we divide by 2? Because guys, as I told you, in the first side, the spring is suspended by this wire, so the 5 Newton for this side, the other side 5 Newton too. So the rod it's divided by two sides, 5 for the right, 5 for the left. So each springs they need 5 Newton for both. That's why it's become 10. So 10 divided by 2, 5. So that's why, and instead of each tension and instead of each t, write 5, because this t is a tension of spring. So this t is here, it's 5, and this is in here, it's 5 too. That's why, because in each side, as I told you, the spring is suspended by this side. In the first side, the spring it's suspended by this side, and this in here it take 5 Newton, and the left side take 5 Newton too. That's why the total is 10. So divide the tension by 2. So instead of the t, directly write 5. But the previous part, directly we wrote 10. Why? Because both of them they are suspended. Both of them they are connected by this subject. So both it's 10. That's why. Guys, we finished all this chapter. We finished chapter 2 and we solved the important example. I hope to get the benefit from me. Thank you for watching my channel's YouTube. You can subscribe and send to your friend. Share the video with your friend. Thank you so much, and have a nice day.